We're going to start looking at simplifying rational expressions and solving rational equations. Now, you may have gotten some of this in your Algebra 2 class last year. Kind of depends on how far you got. But a rational expression is going to be a quotient of two polynomials. So some examples are there below. And remember, we've already talked about this year and from last year that the domain of an expression is the set of all possible x values. This is going to be really important when we're looking at rationals. Remember that the two reasons why we might need to restrict the domain would be dividing by 0 or square rooting a negative, or fourth root, sixth root, any even root of a negative number. So with rationals, since we're going to be dividing by a polynomial, determining where the denominator equals 0 is going to be really important to deciding what values we need to exclude. So for example here, in the first three examples, we want to find all of the numbers that must be excluded from the domain of each. In these cases, the numerator does not matter at all. We are only looking at the denominator, and so we need to set all of the denominators equal to 0. Well, if x plus 5 equals 0, that means that x equals negative 5 has to be excluded. So we can say x should not equal negative 5. That's our excluded value. For this one, if I factor this denominator, we get x plus 6, x minus 6, and if we set that equal to 0, we see that x cannot be negative 6 or positive 6. And for number 3, similarly, we can factor this denominator. We get x minus 7 and x plus 2. So that tells us that x cannot be negative 2 or positive 7. So that's how we determine what needs to be excluded. Now, one of the things that we're going to practice is simplifying our rational expressions, okay? A rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1. This is exactly the same as what we know about simplifying fractions. 2/3, for example, is simplified. The only thing I could divide both 2 and 3 by would be 1 or negative 1 in that case. Something like 5/10 is not simplified because both of those can be divided by 5. So that's what we're looking for. We're not working with numerical values, though. We're working with polynomials. The rule is you can only cancel out factors, okay? Never terms. So here's the steps we're going to follow. We're going to factor the numerator and the denominator completely. And then you're going to divide the numerator and the denominator by any common factors. We're looking for ones. Now, again, be careful when we use that word cancel. Yes, we're going to cancel factors out, but they cancel because they divide out to 1. This is important if everything cancels out. You don't end up with nothing, you end up with 1. And then we always want to figure out the excluded values based on the original denominator, not the simplified denominator. Now, here's two things that I want to point out that we want to be very careful about. We can only ever cancel factors. Factors come from multiplication. X plus 2 times x minus 5, that's multiplication. Those represent factors. 3x, 3 times x, those represent factors. We can never cancel terms. So here's what I mean. Here's what we can do. I have 2x on the top, those are both factors, and I have 6 times x plus 1. So 6 is a factor, x plus 1 is a factor. We can divide the 2's out on the top and the bottom, which leave us with 1 and, whoops, I forgot this here, 3. So that is fine. Here is what is not fine. If I had 2x over just 6x plus 1 in the denominator here, this is addition, 6x plus 1. There's nothing factored out down there, so we cannot do that. This is always, always, always going to be bad. That is never allowed. You can only cancel factors. Okay, so here is the process. Let's look at a couple examples of simplifying. The first step is always to factor everything out. So if we look at the numerator and the denominator, we can come up with the factor x squared times x plus 3 at a GCF, and then the denominator is not factorable. Now, because a fraction bar acts as a grouping symbol, we can add those parentheses here, and now we can see that on the top I have factors. This x plus 3 cancels with this entire x plus 3, and so the answer that we are left with is x squared. Now, the excluded values are, remember, anywhere that makes the denominator equal to 0. So we would want to add then that x cannot equal negative 3. That's what we get when we simplify. Let's look at number 5. Again, the first thing that we need to do is factor, and so we will get the difference of squares on the top and a perfect square on the bottom. So this is how that factors. Now, up on the top, we have x plus 1 to the first power, and in the denominator, we have x plus 1 to the second power. So one of these is going to cancel out, but we're still going to be left with one of them in the denominator. And so what we end up with then is the x minus 1 over x plus 1, and that's it. Now, you could leave these in parentheses if you want. That's also correct. Doesn't matter. And then the question is, again, what would make the denominator 0? Well, that's x plus 1 squared, so x cannot be negative 1. All right, go ahead and pause your video and try number 6 on your own. I'll be back in 3 with the work and the answer. All right, you should get that the x, whoops, I canceled out the wrong thing there, didn't I? This one does not cancel. This one does. And so we're left with x minus 5 in the denominator. Here's what's really important. The excluded values come from the pre-simplified form. So even though the x plus 5 canceled, we still have to exclude negative 5 as well as positive 5. And so those are our answers. Okay? We're now going to look at multiplying and dividing rational expressions. If you can simplify, you can multiply and divide because they're the easiest thing to do. So when we multiply, remember that we multiply fractions straight across. So if I have a over b times c over d, we get ac over bd. So you can just go straight across. So the process is exactly the same. We're going to factor all the numerators and denominators, then divide out any of the factors that they have in common between the numerators and denominators. Now, since you multiply straight across, you can really imagine it as one big fraction. So you can cancel out from either of the two fractions. It doesn't matter. Okay? And then we multiply straight across. Now, you could do step 3 before step 2. That's kind of how I like to do it. It doesn't matter. The excluded values, again, come from the original factor denominators before you start canceling stuff out. So let's look at example 7. Step 1 is to factor everything completely. And so we are going to see what we can do here. Now, x minus 7 does not factor. X minus 1 does not factor. X squared minus 1 is a difference of squares. That's x plus 1, x minus 1. And 3x minus 21 has a GCF of 3. Okay, now again, because we're going to multiply straight across, you can imagine this as one big long fraction bar, which means we can start canceling stuff out from both of the fractions. And we are left with x plus 1 over 3. And that would be our answer. Now, again, we have to look here before canceling happened to determine our excluded values. So x cannot be positive 1 or positive 7. All right. Pause your video and try number 8. I'll be back with the work in 3. All right, here's what you should get. Now you can see how important the factoring is here, and you can see as well why it's so important that we can factor quickly, because these problems can go really fast if you can factor these quickly. They're going to take you a little while if you have to do scratch work out to the side to factor every single time. Okay, last thing that we're going to look at is dividing. Dividing is very simple. whenever we divide, we want to change it to a multiplication problem. And what you probably remember, this is the way they tell you in middle school, is when we divide fractions, we keep, change, flip. So that means keep the first fraction exactly the same, change the division to multiplication, flip the second fraction. So we're going to multiply by the reciprocal. So the process otherwise is identical. We're going to start by factoring. So this one, what multiplies to -8 and adds to -2, I get x minus 4, x plus 2. X squared minus 9 is a difference of squares, x plus 3, x minus 3. This one, they're both already factored, but now this is where we're going to change to multiply, flip the fraction. Okay? Once we have that, now we know how to multiply, so we know what to do. X minus 4's divide out, x plus 3's divide out, and it looks like all we have left is x plus 2 over x minus 3. Now, excluded values are a little bit trickier because we have to look in two places. Anywhere in the process that you would have divided by 0 would be bad. So the x plus 3 that was originally in the denominator was bad. The x plus 3, x minus 3 is bad. And then also now the x minus 4 is bad because we flipped our fraction over. So we have to look in those four places. So x cannot be -3, that's from this guy. Then we also get a -3 right here, so we don't need to repeat it. +3 and +4, and that is our answer. So once again, I'm going to ask you to pause and try number 10 on your own. I'll be back in just a moment. All right, so when we factor, we get that factor of x squared plus 1. Be careful that you don't mistake that for a difference of squares. Remember that the sum of squares is not factorable at all. So x squared plus 1, nothing more that you can do with that. But it's fine because we end up getting both of them together. Also notice x squared plus 1 is never going to be equal to 0. If you square a number, you're going to get a positive, and then you're going to add 1 to that, so you don't get any excluded values from that. Okay? So simplifying, multiplying, dividing are going to be the things that you are practicing today, and I will see you next time.